Hey, hello class. Welcome to our fourth lesson in quadratics. And so here we're going to be doing the skill of finding the vertex. The focus of this lesson will be on completing the square, but it's important to understand that the goal isn't to complete the square. The goal is to find the vertex. And so that's why when we look at the success criteria, finding the maximum minimum is what we're actually asked to be able to do. We're still looking at the plans to solve, but can we do that in factored form? That's a different skill than completing the square. But then if it's in standard form, if you've adopted this method called partial factoring, it's a really interesting method. It's something we did in class. I'm sure I could maybe see if we can link a YouTube video for partial factoring. But the focus of this lesson is going to be completing the square, but you don't have to ever do it by completing the square. Like, you could do it both ways. So the first question is asking for the vertex, and so you notice that if you have the factored form, you get the zeros, and if you have the zeros, you can get the vertex. It's between 3 and 4, or 3 and 5. So the vertex is at the axis symmetry when x is 4. When x is 4, y equals -1. In the second one, just realize we are in vertex form, so the vertex is actually 4, -1. And it's going to be the same graph here, but and the reason why is not because it's really for transformations, but if you actually sub in x equals 4, you get y equals -1. I'd be really hesitant to try to remember, oh, this sign changes, but this doesn't. Really just think about what values you sub into here, and then the negative that makes this 0, and then y equals -1. And then the last one is actually factorable. So it's important to see that if it's in standard form, if we can factor it, then we have as much information as we have if we have factored form. So sometimes if it's a simple trinomial, it doesn't hurt to just check if it can factor, and then you could potentially get the zeros, just and it's the same question. And actually, these are all the same. This is factored, vertex, and standard form. So state the vertex here. First question is just, and the goal here is to actually learn how to complete the square. But the goal, the first question is just to show you that. So I asked the question is this in factored form? Is it in standard form? Is it in vertex form? And so you'll basically get half people saying, oh, it's in factored form. It's x minus 2, x minus 2. But then a lot of people say, oh, it's in vertex form because it's x. The vertex would be 2, 0. And so both of those are actually right. And so the point of this is to actually show you that this overlap of standard form or factored form and vertex form is actually really important. And this is what we call the perfect square trinomial that factors like that. So the vertex is 2, 0. The second one, it actually factors to x minus 3, x minus 3. And so you get x minus 3 squared. And so not looking at a different technique, still factoring, we see we've actually got vertex form. The third one, if you were just to state the vertex, you probably would just factor at the x, and you got x plus 6 inside, and you can find the zeros that way because that's factored. But what we want to do is highlight the fact that if that number on the end, it's 0 right now, if there was a 9 there, we could actually factor it just like this. So I actually just put a 9 on there. But then the question, it's always interesting, funny, can you just add a 9? No, you can't. That's illegal. And so you'd have to subtract the 9 right away. And you're actually allowed to do that. You're actually allowed to add and subtract anything you want. And it still creates the same thing. It's still x squared plus 6, 6x. And so in realizing then, if we factored this, we would get x plus 3 twice, just kind of similar to here, x plus 3 times x plus 3, and then minus 9 just shows up on the end. And so now the question is how did you get, where did the 9 come from? It's not just part B here. What if we didn't know that 9 was there? And the answer comes right around the idea of well, if you expanded this out, you see that the only the 3 comes from half of the 6, and so if you expanded this out, you'd get 6x. And the only way you could put a number here so that when you add it twice, you get the middle number is if you take half of the 6. And so that's why it's a 3. The reason why it's a plus 9 is because like after you have the 3, you can square it, you get the plus 9. And so there's going to be this relationship between the b and the c term that actually helps us create vertex form. The next one, like we actually have a plus 9, but we don't want the plus 9 now. And so just looking at the x squared minus 4x and saying, well, if it was plus 4, then that would be good. Because then it would factor nicely to x minus 2, x minus 2. But when we added the 4, we actually have to subtract it off right away. And so if it was x squared minus 4x, we actually want plus 4 on the end. And then with the subtract 4, we actually get x minus 2 squared minus 4. Now we don't have 0. We've got a plus 9. We don't have a plus 4. So like you can subtract 5 and add 5, but I'd probably just throw the 9 over and do this work in the middle here. And then realize you can put the negative 4 with the 9 after, and that gets you the plus 5. Okay, and this is what we call completing the square. And it's basically just creating the conditions so that you can factor these first 3 as a perfect square trinomial, the same thing twice. Next question, we factor out we have an a value now, so this actually only worked if the a value is 1. So if the a value is 2, we can actually create the conditions where the a value is 1. So we do that just by taking the 2 out. We don't take it out of the 5. The 5, just like the 9, it just is kind of just hanging out on the end. It's not the number we want there, but we're just going to leave it alone and put it with the number that we end up getting. So we just take the 2 out of the 2x squared and the minus 8. And then we saw it's plus 4 minus 4. We've got to get that negative 4 out of there because this guy's in brackets, but you can't just take the negative 4 out. You've got to multiply by 2. And then this middle part here factors to x minus 2 times x minus 2. So we get negative 8 plus 5 is negative 3. So the vertex is 2 comma negative 3. So the question is, how do you get that last term? So if you're in this form or this form, and I didn't use, I probably shouldn't use b here, but I like just for the sake of describing the number, I just used b, and so because b is really, this is really abx, and we just call it b. But what we need is half of the b and then squared. That's the number we want to add and subtract. And the reason why is because, like, if you look at expanding this guy out again, it's got to be minus 2 is the number that's half of the negative 4, because when we add it twice we get 4. But then the reason why we square it, so we half it first then we square it, because negative 2 times negative 2 has to be plus 4. And so the number that we're looking for is the number in the middle here, so this 4, half of it, and then squared is the 4 minus 4. And so we'll see like one with, that's a little bit trickier. This question here, so what do you know? What do you need to know? How are you going to get there? So you know, like the equation, you know that you're trying to figure out what you need to know is trying to figure out how high, like if the ball is going to hit 185. One of the strategies we talked about how you're going to get there is to actually find the vertex. And so we can do this question by solving for the vertex. You can also do this question by solving for the roots at 185. But if it doesn't, the vertex will actually tell us if it's going to hit above or below 185 anyway. So realize that you can do this by factoring. So if you've already factored it because you've already found out when the ball is going to hit the ground or something like that, it's nice, and it might be the best method if you already have factored form. You probably wouldn't do this if you knew you had to find the vertex. It's not a strategy, create factored form, because like factored form is not always something you can create. But in a case where you already had factored form, take the 5 out and then simple trinomial, we could get the zeros, and then right in the middle of the zeros is the axis of symmetry. So we add them up, add up the zeros, divide by 2. And so then the axis of symmetry is right at 4. Then if you sub 4 in to the equation, and I'd probably sub it into the factored form, it's just a little bit nicer. you get -5 times -6 times 6, which is 180. And so the vertex is at 180 of a height, a t value of 4. And so you can see it's never going to hit that orange line, which is actually at 185. The other method for doing this is actually by completing the square. And so we take out the -5, just like we saw before, leave the 100 alone. We half the 8 and square it. So the number that we use to complete the square is actually 16. So we add, subtract 16. Take out the -16, because that's not part of the factors we want. So we get 80. And that's actually like the plus 80 plus 100 is actually going to be the vertex. Then you just factor the simple trinomial inside. So t minus 4, t minus 4. And it always factors to the same thing twice. And so you got the vertex, 4, 180. So you can see it's not going to hit the power lines. Okay. Vertex of this guy, if we look at it, we can do this in two ways. We can do this in fractions and decimals. I'd encourage you to try it with fractions. Certainly, when the pressure is low and you're practicing it. Like for me personally, I like it better with fractions. It means I don't have to necessarily pull out a calculator. The decimals aren't so bad in this question, but and sometimes you have to use decimals. So it's just like a matter of making sure you understand both methods. So with fractions, like we take out the 3 either way. Leave the 2 alone, it just stays on the outside. Half it then square it, so half of 3 is 3 over 2, and squared is 9 over 4. Half of 3 is 1.5, and squared is 2.25. So it's the same thing, it's just 2 1/4 instead of 9 over 4. Get the 9 over 4 out of there, it's really 27 over 4. Get the 2.25 out of there, it's negative 6.75. Then you factor the trinomial, and then like you're gonna have to do a common denominator here. And since you're over 4, you can just change the 2 to an 8 over 4, and then 9 times 3 is 27. Factored is x plus 3 over 2. It's the same number twice. X plus 1.5 over on the right side. And so factored form looks like this, with the vertex at -3 over 2 and -19 over 4, or -1.5 and -4.75. Okay. The next question, we're looking at the riders. So we've seen this question before, and so we talked about like what do we know, what do we need to know. So we actually know factored form, and it doesn't look like that right away, but we actually have what we need to know is maximum revenue. And so part of what you know is actually factored form. You got to create that model, which is more of a goal for the next lesson, but we're gonna kind of show how we know this right now. And then how we're gonna get to the vertex is really just using that method of finding the axis of symmetry with the zeros, because we realize we're going to get factored form first. The key is letting x represent price increases. That's what's actually going to change. So the price is a linear equation based on just the number of changes that you make, and the quantity is a linear equation based on the number of changes you make. So it's going to like have a y-intercept of 56,000 start, and then a slope of down 2,000. This one has a y-intercept of $2 and then going up 10 cents each time. The quadratic comes when we multiply the 2 together, and that's where we get factored form. And so realizing we need the vertex, we've got factored form, we know that. Now we just find the zeros. So we like kind of solve these little mini equations. Temptation is to like start expanding it out and then quadratic formula, but you can easily find the zeros just by like solving these linear equations. The midpoint of the zeros is the axis of symmetry, so it's 4. And then if we subbed in 4 into the equation, we get our price and our quantity. And so you can see that in the 2 equations there. And the revenue is, if you wanted it, was 115,200 if you just multiplied those together. Okay, and that's it.